So this is a continuation of the two-stage amplifier. The voltage at the base here is 3.508 volts. Voltage at the emitter of 2 is 2.808 volts. Now we need to find out how much current is here so we can figure out what our prime E is for Q2. Current through RL is, let's see, IRL is equal to 2.808 volts divided by 270 ohm. IRL came out to 10.4 milliamps through RL. Our prime E came out to 25 millivolts over 10.4 milliamps, comes out to 2.404 ohms. The thing to notice here is that the more current you have through the collector, through the emitter, the lower R prime E is going to be. So we found IRL, R prime E, Z out. Remember Z out, we'll have to Thevenize this circuit. Thevenize says you remove RL and you look into the circuit. So what we see is the R prime E here, right there, and a path to AC ground of 3.6 k ohms. Notice this 3.6 k ohms is after the transistor. So after the transistor, you divide by beta here instead of multiplying by beta, as we were when we looked into it this way. So we end up with R prime E 2 plus 3.6 k ohms divided by beta. We end up with 2.4 ohms plus 36 ohms. We have a Z out of 36.4 ohms, which means if you're looking at a Thevenin equivalent circuit, maximum power transfer happens 3.4 ohms when we have a 38.4 ohm load. This transistor circuit can output a lot of current. Current comes from the collector down through the emitter, through the load, and the only time you'll have voltage drop here is when you get somewhere around there in resistance on the load. So 50 ohm load on this device would regulate quite well. You notice the voltage here is what regulates the voltage here, and the current comes from the collector on this. We have only a voltage gain of actually less than 1 because our prime E is part of it, so you'd still have a voltage swing across this that was comparable to that.